Hey folks, this is the fourth and final video from section 5.1. So if you will please go all the way down to the section that talks about coterminal angles, we'll deal with this terminology here. All right, coterminal angles. Well, if you think about the word coterminal, terminal we already know is like my terminal side is where my terminal side stops. It forms my angle. We talked about that in the first video. Coterminal just means that we're going to be terminating together. Mathematically, it means we've got two angles. Both of our angles are in standard position. Both of our angles have the same initial side, and both of them have the same terminal side. Two angles are going to be coterminal if their measures differ by either a multiple of 360 degrees or 2 pi radians. And for these, I like to think of this instead of in numbers, I like to think of that, oh, that's just one whole circle. All right, so some examples of coterminal angles. If theta is 50 degrees, you can see here is my initial side, and there's my terminal side at 50 degrees. Or I could also have 410 degrees. Here's my initial side. I have to go all the way around, but I'm going to still stop at the same place where that 50-degree angle stopped. And so they have the same terminal side, they have the same initial side. Same thing over here. If I have my theta at pi over 6, and if I decided to go in the negative direction, 11 pi over 6. Now, I want you to think about this. This is 11 pi over 6 is just short of 12 pi over 6. So 12 pi over 6 being equal to 2. So we took pi over 6 and we subtracted, because this is negative, we subtracted a whole entire circle and landed in the exact same spot. So for number 6 then, we are looking for both a positive angle and a negative angle that are coterminal to the given angle. For the record, there are an infinite number of answers to these two questions, this part A and part B, because I could add one whole circle, I could add two whole circles, I could subtract 5 whole circles. There's an infinite number of answers. I'm just going to give you the two closest angles, the first positive and the first negative, essentially. All right, so we're going to take 110, and we're either going to add or subtract one whole circle. So again, 360 degrees is a whole circle, so we're going to add or subtract a whole circle. When I add a whole circle, I get 470 degrees. When I subtract a whole circle, I get negative 250 degrees. For negative pi over 4, again, if we add or subtract a whole entire circle, that's going to be adding or subtracting 2 pi. Notice that when we're in degrees, we work in degrees. When we're in radians, we work in radians. Let me challenge you, let me encourage you, don't automatically switch everything over into degrees just because it's easier for you. Force yourself to work in radians. It will benefit you as we work through the semester. All right, so when we take negative pi over 4 and we add or subtract 2 pi, I want you to think of 2 pi as the same thing as 8/4 pi. Think of 8/4 as the same thing as 2. So negative pi over 4 plus 8 pi is going to be 7 pi over 4. And negative pi over 4 minus 8 pi over 4 is going to be negative 9 pi over 4. Again, there's an infinite number of answers, but these are the two closest answers. All right, next, find an angle between 0 and 360 that's coterminal to the given angle. So you have 910 degrees. Now, if I just take 910 degrees minus one whole circle, I'm still not going to land between 0 and 360. So on this one, I actually have to subtract 2 whole circles. So in my calculator, I'm probably going to do something like 910 minus 360 minus 360. Or you could type it in the way that I hand wrote it here on the notes. And that's going to give me 190 degrees. For negative 80 degrees, I need to add a whole circle. And when I add a whole circle, I get 280 degrees. Now let's do the exact same thing for question number 8, only this time we're working in radians. So I want all of my angles to land between 0 and 2 pi. So for 17 pi over 6, remember thinking that 2 pi is the same thing as 12/6 pi. So 12/6 is smaller. So what I'm going to do is I'm going to subtract a whole circle, but when I subtract that whole circle, I'm going to think of it as 12 pi over 6. So 17/6 minus 12/6 is equal to 5/6. Don't forget your pi. All right, for this one, we're going to add whole circles. Now, what I did on this one, since we're working with twelfths, I didn't use 12/6, I used 24/12. Again, we are adding a whole circle, but I immediately saw, that's not going to be enough because that's still going to be a negative angle, so I added another whole circle. So combine your numerators, negative 35 plus 24 plus 24, and that's going to give you 13 pi over 12. All right, the last question for this particular section is going to be a story problem. So you have a wheel, and this wheel spins at a rate of 40 revolutions per minute. Now think about the fact that one revolution is one time around the circle, so that's going to be 360 degrees. But I've got 40 of these revolutions. So if every one of those 40 revolutions is 360 degrees, then we've got 40 times 360 degrees for my total number of revolutions in every single minute. So what I did was I set this up in a fraction. We've got 40 revolutions. Each one of those 40 is worth 360 degrees, and it's for every minute. All right, so this is setting it up in fraction form. All right, but I don't want 1 minute. I want to think about 5 seconds. So let's read the rest of the question. Through how many degrees, so ultimately I want my answer to be done in degrees. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Okay, so we know how far it goes in 1 minute. We want to know how far it's going to go in just 5 seconds. So the first thing I'm going to do is change my 1 minute into 60 seconds. Notice I didn't change the top. I only changed the bottom. At that point then, I reduced my fraction. I just put into my calculator 40 times 360 divided by 60, and I got 240. So what this meant then, as I'm reducing and using my units, I have 240 degrees for every single second. But again, I don't want 1 second, I want 5 seconds. So then what I did was I multiplied by a 5 on top and on bottom. It's legal because it's equal to the number 1. And then that tells me that I have 1200 degrees every 5 seconds. So through how many degrees does this point travel? It will travel through 1200 degrees every 5 seconds. All right, that's a wrap for section 5.1. Please let me know if you have any questions.